Okay, I think we're ready to get started. Welcome to the Adaptive Computing webinar, Why Adaptive Computing in Oracle Cloud Infrastructure. You'll see how to burst to Oracle Cloud Infrastructure today, and I'll introduce you to our panelists. We'll be bursting from on-premise systems, running workloads in the cloud using the on-demand data center, and we'll also be able to see the performance capabilities and benefits that are available only in Oracle Cloud Infrastructure. So Rian, if you could just flip the slide real quick. Our panelists today, first of all, thank you for taking time out of your day to join us. We really appreciate that you've joined today. And our panelists are Rian Venter, who is the Senior Solutions Engineer from Adaptive Computing. We've got Anoop Ojwa, who is the Senior Manager Global HPC Cloud Engineering at OCI. And we have a special unexpected guest today, our CEO from Adaptive Computing, Art Allen. So we're very glad that he's joined the call as well. So in case you're not familiar with Adaptive Computing, I'm just going to spend a real short amount of time here talking about who we are and what we do. And we're known for HPC workload scheduling and cloud solutions. We're a trusted leader in the high-performance computing and enterprise software space. Adaptive has provided advanced applications and tools to some of the world's largest computing installations. We've been around for over 10 years. Thank you, Rian. Some of our industry verticals are oil and gas, financial, manufacturing, research, academic, and government. Go ahead and hit the slide again. Adaptive has over 200 supercomputing customers in some of the world's most demanding IT environments. These are some of our customers below, and you may recognize some of these names. We have a very strong customer base in enterprise, in government, and with defense contractors and large universities. So go ahead, Rian.
Good day, everybody. My name is Rian Venter. As Sue mentioned, I'm a solutions engineer at Adaptive Computing. I do work a lot with multiple of our different departments, working closely with our sales, development, and so forth. So I do have a broader kind of a spectrum of what's going on. So today what I want to like us to do is go through a few slides talking a little bit more about our on-demand data center. And then we will go through a demonstration where we will use our on-premise scheduler, our high-performance computing scheduler, MOAB, and using our ODC Connect, which is a bidirectional communication with on-demand data center, and I'll show you some of that environment. Right, so some of the key points on on-demand data center. It's extremely flexible, scalable cloud management platform. You would notice there when I go into the user interface that it's extremely user-friendly, especially people that nowadays don't, I want to say everybody, but many people that prefer using a user interface not being that technical, preferring not to use command line. You'll notice that it's very easy to use it. It's actually specifically built for that. And specific functionality, we're talking about cluster elasticity, where you could, for example, you've got a cluster that's got, let's say, 10 nodes, and you've got workload coming in that requires more than that. If you've chosen that option, it will actually add those additional compute nodes for you on your cluster so that your workload can actually be taken care of. We do support, let's call it the bigger or most commonly used containers, Kubernetes, Singularity, and Docker. And when we talk about a parallel file system, I'll show some slides later on where we're talking about data usage and how do we manage that. But this is where your parallel file systems are also incorporated. So you have a file system anywhere on your on-premise, in the cloud, wherever it's residing, and then you can actually start, using input data, writing output to another file system somewhere else. And as I mentioned, we will show you how we use our HPC scheduler called MOAB, but you don't need a scheduler. So you could run everything purely in the cloud, or you could use another scheduler that we could interface with. We've done extensive testing especially when we're talking about bursting. So I'll be talking about that in the next slide, but it's important to mention that there is at least a 50% cost saving when we start using the automated functionality from on-demand data center. And if you look at some of the use cases, we've got multiple others, but some of these are quite important, especially when we look at workload management, where you want to manage your workload on-premise as well as in the cloud, or you could have a hybrid environment where you want to run certain of your workload on-premise and some of them in the cloud. So that's all choices, really. You can decide how you want to do this, especially in the HPC market nowadays. People are cautious in moving into the cloud, and we fully understand that. But most of the HPC organizations realize they need to get into the cloud. So all of them are starting to look at that. And this is where our on-demand data center assists you in managing your workload on-premise as well as in the cloud. And nowadays there's much more requirement for AI, machine learning, deep learning kind of environments, and this is where your GPUs start coming in. So you start getting access to those kind of resources to assist you in running those kind of workloads. And then data analytics, and you're talking about certain specific environments, especially scientific labs, universities, government institutions are running a lot of different types of simulations and so forth. That's where CAE, EDE, VFX rendering are become a requirement, which we do run fully on on-demand data center. And another example is, and that's more in the enterprise world, where you, for example, have your DevOps environment. You've got a team of developers that test their code during a day, but they do require cloud resources. So they deploy their resources in the cloud, they use them. End of the day, they say, well, they kind of forget about them and they just knock off and come back the next day. Now, in the meantime, that resource has been remaining persistent, as we call it, meaning it's available all the time, but you've been paying for that all the time. And this is where using on-demand data centers bursting functionality, you can actually terminate those if it's not in use. Now, if we're talking more specifically about the bursting side, as we've mentioned before, I've just mentioned before that you've got different ways or different types of clusters that you can make use of. The obvious one is a persistent cluster that it's always available 24/7. So whenever you have workload that needs to run, it will be available. Only thing is that you're consistently paying for. But when we start using our bursting functionality in on-demand data center, we've got different options that we make available. A few of them are max means, let's say I've got 20 nodes available on my bursting cluster. They're actually down when there's no workload. Workload comes in. If I've got my max option chosen, it will give me maximum available resources based on what is in my workload queue to get that done as quick as possible. When we use minimum, we will run your workload sequentially, meaning it will be done one after another. It will get done, but that's more from a cost saving point of view. And we've had the option to deploy all my instances, irrespective if it's one job that requires one node, one core, or if it's 100 jobs, just deploy everything for you. That's another option we've added. There's additional functionality, which we call on demand, that if you just want ad hoc, very briefly, very quickly, just want to run one job, you use the on-demand option where you configure your cluster, deploy it, it takes care of your workload, and it destroys the cluster. You can keep your cluster up if you want, but just to get your immediate workload done very quickly. It's just an ad hoc. It's not part of, for example, your batch run. So there's another option to do, using the on-demand functionality to get that done for you very quickly. And as I mentioned before, you can resize your clusters based on your workload and based on what the requirements are. Now, continuing a bit more on the bursting side. Now, this is kind of just going through what I've just explained, where we've got your minimum, max, and burst all options. and you've got a persistent cluster. And I mentioned the on-demand. Now there you've got multiple sub-options, if you want to call it that, where either you can destroy your full cluster as soon as your workload is done, or keep my head node up and running, or keep my head node and just take my compute nodes down. That would be similar than bursting, so then you switch on your bursting in fact. So it's just showing you where on-demand data center job queue, as soon as there is a queue in a workload coming in, then these are the different options that you can use the bursting functionality to actually take care of your workload. Now, this is where we talk about a single pane of glass, where we know there are people that prefer using the command line side. We know there are people preferring using the graphical user interface. So that's where you've got the options. And again, what I'll be showing you, you'll mostly see the graphical user interface, but everything available on the user interface is also available on your command line side. So it's, if you prefer doing it that way. And by bringing all the different, let's call it the service providers, multiple clouds, together in one place is multi-cloud orchestration. So you could actually have agreement with one of these service providers or multiple of them, and you could have clusters with each one of them all being managed within one place. And that's why we're talking about a single pane of glass where you can see everything going on within your cloud environment. Now, this is just talking a little bit about, you know, what I've spoken about, how we bring it all together. And this is where we'll also I'll show you in the demonstration where you've got your job scheduler, which in our case, we will be using Moab, our high performance computing scheduler. People may be familiar with it. And again, you don't need to use that. It could be another job scheduler, or you could be running your workload directly on on-demand data center, as I like to call it, a peer cloud environment. And then we've got the interface between your on-premise and your cloud environment. And we've got something called on-demand data center connect. Now that is where I can define my scheduler to say, right, if my on-premise environment is fully utilized, more workload comes in, what should I do with it? While I've set this up, it knows there are cloud resources available, and I can move that workload into the cloud so that there's no backlog. You know, typically things that happen is I've used all my resources, the rest of the workload just have to wait. Or you've got the option to use your scheduler functionality like Moab, where I can tell it, listen, I just want to run in the cloud, even though being submitted on premise. It will run it on the cloud, or keep it on premise, or use a hybrid kind of scenario where you say, right, run certain things on premise. For example, some kind of scientific guys, they run jobs that run maybe 24 hours, 48 hours. Now you can run that on the cloud, but they may not want to do that based on cost. So keep that part on premise and the rest you run in the cloud. So that's different options of choosing how you want to run this. And then on the right hand side in the gray block is where we've got our on-demand data center. I'll show you a little bit more in the demo itself, but in brief, we've got as we call it, a base stack. Now that is a combination of pieces of software that actually gets kind of combined within as we call it, a stack build that creates you know, an image within your service provider. And you'll notice that, you know, we're talking about only Oracle in this case. Previous one I had some of the other providers as well. One of our colleagues, Anup from Oracle, will be talking a bit later about, you know, the Oracle side, and in this case, I'll be running a demonstration on one of the OCI's environments. And this is how we kind of bring it together. So you obviously have to have credentials that from your service provider so that you can actually do that. And then we can, then you define your credentials within your on-demand data center environment. And then we've got a stack that's built. You first have to have your credentials, and then we build that image, which includes all these different environments, which already by default, we have certain applications already available like MPI, OpenFOAM, and so forth. And all your, you know, your compute environments, your data, your operating system, and so forth, that we bring that together, and your cluster actually uses that when you do the configuration of your cluster.
Okay, Rian.
All right.
Rian, just real quickly, we have a question that came in, so I wanted to give the answer, the question to the panelists here. All related. Okay, so the question is, you mentioned provisioning nodes in the cloud. Do you mean that you are deploying bare metal full node instances, or are you deploying typical instances, AWS term, don't know Oracle term, which are slices of systems? Do you have a full control of the instance type? Can your cloud cluster have a mix of instance types?
It could be a normal virtual machine, it could be bare metal, especially on Oracle that are very strong on the bare metal side. Obviously GPUs and so forth. So it is really a choice of instances that's available from the OCI side.
Yeah, and Rian, let me add just to that, some of that question, answer some of that question as well. The clusters and the nodes can be homogeneous or they can be heterogeneous. So you can have a mix of nodes and cores. It doesn't have to be all the same configuration.
Right. Yeah, that's a very good point. Thank you, Mr. Allen. If for example, and I'll show that to you just now in the user interface part of it, where you could have different types of instances. Now, whether it's bare metal, you can combine that with virtual machines or GPUs, making it, an environment where you could pick and choose really what kind of instances you would like to run. Right. So just a few slides on, we call it data anywhere, where you kind of how we manage the data, and I think that's important because that question do come up a lot. People ask, well, what about my data? So in this first example, and this is actually came with one of our prospects that actually asked the question that, so, well, I've got, for example, 10 terabytes of storage on one provider and another on another provider. It's duplicated. So do I really need both of those on both providers? And we said, absolutely not. You can move that one part of your one provider, or you can remove that, and by using on-demand data center, you could actually from the one cloud provider access the same storage, and also on the other provider also access that from that provider, so access that same storage. You don't need to save all of that data, and that's a huge cost saving for them. So that was one of the examples of to manage your data, and that's purely in the cloud. Now, one other customer asked us, well, so I want to run my workload in the cloud, but I do not want to move my data with my job into the cloud. And absolutely, so I got it set up for them where they keep their input data on premise, they run their workload on the cloud provider, and we generate access by means of scripting. And we've got a VPN set up to that data on the right hand side by means of a VPN connection, and the input data was mounted on a shared directory. They could read the data from my workload running in the cloud, and then when you're done, you just dismount that and disconnect your VPN or keep on using it. So that's just another way of using data anywhere. Now, this one is really, we're talking about, and that's kind of trying to explain data anywhere. It is really anywhere. We don't mind where you keep your data. And you'll recall in the beginning I mentioned about, file sharing. And this is where you could have input, output data on some file server somewhere, either in the cloud or on premise or offsite. We don't care where that resides. Your data could be anywhere. We will set up that communication from on-demand data center, whether you want to use it as just reading the input data or writing the output. So it's really input data, output data can be anywhere, meaning data anywhere. So that's really what we're trying to tell you over here. Then, so just briefly what I'll be doing in the demonstration. And I don't want to run shit too much, but I want to give Anoop some time as well. So I'll be submitting 20 jobs from 20 users from a MOAB command line environment. It will utilize a Oracle cluster and run the workload on that cluster. and it's in a bursting mode, meaning the cluster is, the computers are actually down, waiting for workload to come in. We'll run the workload, and then we'll start destroying those compute nodes as soon as your workload is done. So that's really what we're going to show in the demonstration. So I'm going to jump here into my demonstration environment. So over here, and I'll just briefly show you the user interface, and this is where I'll be logging into it. And just out of interest, this environment is actually running on our data center in Florida, and I'm accessing Oracle Cloud environment. Now this is my landing page, which kind of shows me all my different clusters I've got configured, whether they're down, I'm not using them right now, some are actually up and running. And you'll notice this one over here, that's an Oracle one, it's got 20 nodes. So if I go into this one, and I just want to briefly show you that before we start the process, that you'll actually see where that is actually going to start showing up. And remember, this is where we're talking about, you could have multiple providers if that's your choice. We can manage all of that for you from one single pane of glass. Now you'll notice this cluster right now is nothing in its queue. You'll notice that currently its compute nodes are all down. And if you look at the configuration, I spoke about bursting, and this is where it's currently set. And you'll notice that I've got it on all. That means when my workload comes in, whether it's one job, whether it's 100 jobs, start up all my compute nodes. So this is waiting for workload. And you'll notice, this is what Mr. Allen spoke about just now, is different types of instances, right? So in here could be bare metal, could be some VMs, could be some GPUs. It really depends on how you want to configure your cluster. And I'll show, as soon as we start the process, I'll show you a little bit more about how to configure your cluster. So I'm going to go and jump to my actual Moab environment. So where I am now is on command line from Moab, and I want to show you what I'm talking about. We could even on the Moab side, the on-demand data center connect, show you that we could have multiple clusters. So in this case, this is my on-premise environment. I've got 16 cores available. Just some other information about other Moab environments. And then you'll notice I've got 2 clusters defined over here. So one is that one I'm talking about that's got 20 nodes and it's got it available. So we're ready to use that. So I'm going to run my job from here so that we start the process. As I mentioned, I'm going to run 20 jobs. Now, what it will do is, Moab, obviously from a scheduler point of view, is busy taking care of this. And what it will do is it will submit my 20 jobs from 20 different users. Now, you'll notice my one job, and I'm just running one job that is running 60 seconds just to start the process, right? So it will run for 60 seconds, and these next 4 jobs are dependent on that first one. And that, as soon as this one completes, it will move my 4 next, let's call it my next jobs, which also will run on premise. And you'll notice that each one of them requires 4 cores, meaning 16. So my on-premise environment will be fully utilized. And then I've got my 20 user jobs that are each user submitting one job in this case, waiting in the queue. And as soon as these 4 go into, let's call it a running state, these Moab will realize, oh, okay, but here's our actual cloud resources available. So we don't have to wait for on-premise resources to become available, and we start moving those in the cloud. You'll notice that now my 4 jobs are utilizing 16 cores. I showed you my on-premise has got only 16 cores available. And in this case, as soon it takes about 30 seconds or so, we'll start moving these workload onto my cloud environment. You'll notice my first jobs are now moving over, right? So we're not going to stay here too long. I just want to show you the process. Now these workload is being moved into the cloud. As you can see, it comes from an eligible queue into an active job queue. So let's jump to my user interface. All right. So you'll notice that now I've already got 7. Remember just now it was 0. So this will build up to 20 jobs as my queue builds up. And you'll notice that as soon as we call it a bursting cycle. Mine is set to every 60 seconds. So it will check the queue, what's in the queue. And now you'll notice, as I was talking, we are busy deploying automatically. I didn't do anything. So it's one script from my on-premise environment that moved all my workload into the cloud, meaning on-demand data center. And now we are using our Oracle cluster to deploy 20 nodes so that my workload can actually run on. So now I've got my 20 jobs that's in the queue. Obviously, this cluster is in bursting service, so my compute nodes are actually down, and now it's busy deploying. Now, the process that it will follow is, as soon as all my compute nodes are deployed, which takes, it could differ, it's from provider to provider, I want to say it's very close. I would say 3 to 5 minutes potentially. It will start becoming available, and then as soon as it's available, it will move into available state, and then we move it into busy, because it will start looking after my job queue over here. And then as soon as my workload is done, it will move back into available. And then we've got something else called an idle purge, which means as soon as my workload is, all my workload in my job queue is taken care of, what should I do? So I've told mine, wait 120 seconds. If there's more workload coming in that time, we'll take care of it. But if there's none, then we start moving it down into an offline state. And then as soon as my bursting cycle goes over my 60 seconds cycle, we start destroying them again. All automated. And that's why I mentioned that if you've got a bunch of developers that are busy working and they forget to bring down their resources, right? And it could be anybody. You don't have to worry about it. An administrator could be taking care of this from this environment. And as you've already seen, it's very straightforward and simple to use. So while this is happening, we'll just have a quick look at my environment over here. So remember I mentioned credentials. So that's very important. You need, let's call it the correct type of credentials to be able to deploy a cluster in your service provider. We've got the let's call it the instructions how to do that, but you can get that from your provider as well. And you define your credential over here. Then my next step would be to actually do a stack build. Now, remember I mentioned in that diagram that we've got a base image, and the base image means it's a group of software that is actually already available, that as soon as we do a stack build, we bring that software together. Now, that's things like your operating system, certain applications like MPI, OpenFOAM. If you've got already, I'll show that to you as well, that you can start including at this stage a application. So, for example, if I want to add a new one, I choose my provider, and you'll notice over here is a server provisioner and a node provisioner. Now, this is where you can actually add a application already at this stage before actually deploying a cluster. So then your application is already part of your image that you will continue using. And you'll notice that that part over here, it says prefix core. That's important. It's just a name, but it is important because you're going to use that in your cluster definition. Now you've got your stack build completed, your image created, and your image is already created within your service provider. And this is where we go to our cluster manager, where I can add my cluster. So first of all, we do a configuration of that. And you'll notice there's something called import. So if I already have got existing configuration, you can do that. And this is where you define. Now, I'm not going to go into all the details of this. I'll just want to kind of briefly talk about it, that this is where you configure your cluster. This is before you deploy it. So you give it a name. By default, the operating system is CentOS 7. And this is why I've spoken about that prefix, and that's your image name that you are using to enter over here to use that image that you built in the previous step. And you have to have your credentials defined, and we just give it a name. And we first of all, you have to define your head node size. Now, this is what that question that came up earlier is. This is a list. It's a JSON file that we give you the option to actually populate yourself. We're not going to add all of your providers' possible instances in here. It could be hundreds, it could be thousands, right? So you can choose what you want to put in here. And you'll notice that's where one of the bare metal options is available that we've already added in here. And you've got a resource manager, which comes with Moab, which is already available, and you can have Slim as a resource manager as well. And then you start breaking down. Each provider has got different regions. They've got availability zones, and you can enlarge your, let's call it your head node and your compute nodes storage, so you can make this bigger. And this is why I've spoken about your idle purge, meaning if I keep my cluster up for a certain amount of time, by default, 10 minutes. All right, so you can also add additional scripts, meaning you can add, for example, OpenVPN, you can add Python, and so forth. And at this stage, you can already also define whether you want bursting or not, but you can switch it on afterwards as well. And then this is where we define our compute node. So I can have one type over here, and I can add another one. If I prefer a different type of one, then I can add one. So that kind of helps me define my cluster to show. Now you'll notice the little thing over there, and this is not that important right now, but I do mention it, that you could have, we bring available at least an estimate of what you potentially will be paying per hour for that certain instances. Over here, I've chosen 2 different ones. Another one, just to give you an idea of what you potentially would be paying. Right, so then we save this, and you can actually, over here, we can go and then say, right, I want to deploy it. And so, or you can save your configuration, you know, your cluster configuration, and reuse it another time, or share it with somebody else. You've got something called edit collaborators that you can share your cluster with somebody else. All right, so that was all the steps. So let's just go back to our cluster running, just to see how it's doing. Remember, we had our 20 jobs that were in there. It may still be deploying, depending, so it's busy deploying. Remember, I mentioned it could take some time. And as soon as this becomes available, then we'll start moving them into available and into busy. And also, I'll just want to show you some parts of when your job completes, right? So you would want to know what is happening with my output of my job. On ODemon data center, we keep that output for you as well. So for example, let's have a look at this one. You'll notice that it's showing the ones, it will show running because it's busy creating it. If I look at one of my other clusters, you'll notice that output's over here. And this one, just as an example, you'll notice that this was a Docker container that runs a specific application. They call it TensorFlow, and you know, it writes the output over here that it's talking about clothing. How many of that it does a count of that. So it's just different types of applications doing different kinds of things. And I've mentioned about those instance processes. This is where we log that up front when you define your instances, so you can get an idea of, I'm going to configure a certain size cluster, what is actually going to happen with it, and what potentially would I be paying per hour. So it's not exact amount because we don't necessarily include, maybe you got a discount and those kind of things, so we don't necessarily include all of those. Right, so and this is busy deploying. You'll notice that it's still in queue, so it really depends on how long my compute nodes are busy deploying. And I don't want to run over too much time from Anoop because I want to give him at least like 20 minutes. But as I mentioned, the process would be deploying and then becoming available, and then we become busy, and we'll start taking care of this workload of mine. So at this stage, I think I want to hand over to Anoop so that Anoop can talk about with us about the different Oracle environments and how Oracle brings a huge benefit to the whole relationship. So Anoop, I'm going to stop sharing over here and then I'll hand over to you.
Thank you, Rian. Let me know if you can see my screen. Hello, everyone. My name is Anoop. I'm a senior manager from the Oracle Global HPC team. Very happy to be here today. And thanks Art, Rian, and Sue for inviting me for this call today. I also have with me Brian Bennett. He's also from Oracle. He's my colleague. Feel free to ask questions, and he's here to answer on the Q&A chat I think he's going to monitor that window. Well, just before I go, let me see if I can move forward. Just a quick safe harbor statement. I just want to leave it for maybe 15 seconds. I'll let you read. Okay, so let me give some background of myself. So again, my name is Anup. I've been in this industry for more than 20 plus years. And in the last 10 years, I've been working mostly in the cloud, not Oracle Cloud, but AWS, Azure, Google Cloud. I have a lot of experience that I bring along with me. I joined Oracle almost 4 years back. And believe me, this is the journey that I have seen myself. And that was the reason I joined Oracle 4 years back. So we started what we call a Generation 2 cloud. And this was mostly started 4 or 5 years back. We started building this. So what Oracle did was, we are really famous for our database, our applications, our ERP systems. We have a giant company, but we really decided to move towards the cloud 5, 6 years before. So our founder, Larry Ellison, he decided that this is somewhere we want to invest. So we started hiring a lot of smart people. Frankly, we hired the smartest guy from AWS, the smartest guy from Microsoft and Google, and then we built this, what we call a Gen 2 cloud. The reason we built a Gen 2 cloud was, do not make the same mistake that you make in Gen 1 cloud. That was the basis of building this Gen 2 cloud. And then all the smart people that we hired, they knew what was the mistakes they had made before, right? So it was to our advantage that we are a latecomer in this industry. Well, here you go. In the last 4 years, I'm surprised myself, and I've seen this from the very beginning, frankly. Today, we have 31 regions globally live. We are more than any of our competitors today. And in the next 1 year, we're going to add 13 more. So we're going to be almost 44 across the globe. So you can really understand why this is growing. And I'm going to spend some time in my slides to really deep dive why this growth that what Oracle is seeing in the cloud industry, right? You will also see something here, what we call an Azure interconnect. I'm not going to deep dive into that topic, but if you want to understand more about the Azure and Oracle partnership, please feel free to put it on the chat window, and I'll let Brian answer those for me. So let me build this slide. We are the only company that has the SaaS, PaaS, and IaaS. So this is really big, right? So Oracle is #1 in HCM, human capital management, right? So that runs on the SaaS. We have financial applications, we have ERP applications. So, and this is because we have built this from our industry knowledge, right? So we are really good in that area. But the good news is we took that knowledge from the industry and we build our SaaS technology. And that runs on the same infrastructure, the core infrastructure that I'm going to talk about today, right? That's a partnership we have with Adaptive, where they're going to run your HPC workload on the same infrastructure. So that means this infrastructure is proven, right? This is proven to be highly performing and price competitive. Along with that, obviously, we have our platform services. I'm not going to speak about the platform today because the core discussion today is about the infrastructure. So let's keep moving. This is one slide. If you want to remember today what Anup spoke from Oracle, I would like you to take this and go back, right? A very simple slide. There's 5 things that we bring in. #1, security. So Gen 2 Cloud was built on top of security. So that was the very beginning how we started designing the infrastructure. Automation. You saw those 31 clouds regions been built in the last 3+ years, I would say, and mostly in the last 1 year, frankly. It's because of the automation. So we are able to automate the entire infrastructure so quickly that we are able to deploy. So basically, we're deploying one region in every 2 months. So that's really, a testament to what automation we have built within the cloud. And that same automation, you as a customer, you'll get it, right? You get to see and use the same automation that we have in our cloud. Performance is very important. And to really get performance, there's some key criteria that you need to really understand how to build infrastructure, the compute, the storage. So that's how we have built this. And that is why the high performance computing workload is very suitable to Oracle Cloud. This is my number, and so mostly until today, and I believe people will agree with me, less than 5% of the on-premise workload has moved to the cloud, HPC workload, high performance computing workload. And you might argue, Amazon has been here for the last 15 plus years, Microsoft, Google Cloud. Why not more than 5%? Why is people still running the HPC workload on-premise, not on the cloud? Because none of them were able to give them the price performance that Oracle Cloud can give. And we are new in this market, as I said, 3 to 4 years old. But in the last 3 to 4 years, we have seen tremendous growth, mostly from the HPC customers. And I'll, spend some time talking about some of the use cases and some of the customers that we brought in to OCI. Scaling is important, and that's where adaptive comes in. I mean, auto scaling, regular scaling, and adaptive has technology that helps you to scale within our cloud, but we do give the platform. Cost efficiency. I saw, Ryan, one of your slides, or when you're showing up, like for AWS, Oracle, US East, US West, but Oracle does not, segregate costing across different regions. The entire 31 regions that I showed you, cost is exactly the same. We deploy the same infrastructure, even we do not have different infrastructure. It's the same infrastructure, the same cost, the same services are exactly throughout the globe, right? So these are the 5 things I would like you to keep in mind. And if you have any questions, please feel free to put it on the chat. This is a very generic slide. This talks about the overall Generation 2 cloud that we have built. But these are the genesis, why we build the Gen 2 cloud. Very important to understand. From the left side, we call it what we call an off-box virtualization. So this is where we actually give you the performance. So what happens in Oracle Cloud is we have done our networking in such a way that we do not run the same Oracle components or the Oracle services on the same machine that we give to our customer. We have a separate control plane that runs below that. Unlike other cloud, they have a component of that cloud service applications running on the same machine that is given to the customer. So we have completely taken that out of the same box that the customer gets, which means you are getting 100% utilization, 100%. We do not have anything that we run on that machine. That's number one. Security, we can have a large discussion on a separate day, but as I mentioned, obviously security first. Third one, the non-blocking networks. I think this is important. This is just not for HPC. This is in general, like our SaaS model, or platform as a service, or database as a service. The way we have built our networking, I have one slide later on, maybe I'll touch on that. There's non-blocking, which means there's no more than 2 hops across 2 machines, always, guaranteed. And by the way, we are the only cloud who provides SLAs from different layers, like uptime, performance, and there's a few more that we provide SLAs. L2 network virtualizations, that is, again, let's not go deep dive there. We have some more capabilities, but the biggest one is the RDMA cluster networking. And I'm going to spend some time on a separate slide. And obviously compute. So let's check, I might have 10 more minutes. I'm going to go quickly. Let's speak about HPC in Oracle Cloud Infrastructure. I think this is the key. This is why you have all joined this webinar. Well, we have a huge history. We are new, 4 years, I told you, but we're not a new company. We've been there for many, many years now, right? But all what you learn, I think the biggest thing Oracle did was when we acquired Sun Microsystems. We just did not acquire the people from Sun Microsystems. We also acquired their infrastructure, their hardware, their IP. So that really helped us build our cloud. So today we manufacture our own servers, our own infrastructure. That is why we are able to move that fast. That's how we are growing. And all this has come from back in 2010, right? All the experience that we have from bare metal machines to Mellanox to RDMA networking, things like that. That did not happen in the last 4 years. That was all because of the, what we brought along with us for the last many years. Well, let's talk about bare metals. I think this is something that there was a question today. Someone asked about it, and I promise I'll answer. So we are the only true bare metal providers. So there are other cloud service providers out there. They started providing bare metal, but we started from the get-go. And we realized to really move the, that 5% workload that I mentioned, how about the remaining 95? To move that remaining 95, you need to provide something very similar to what you have today on premise. So that's the power of the bare metal. We give you a full machines, and this bare metals, obviously we have virtual machines also, right? Just like any other cloud. We have that, and we have this also. So this gives you almost the similar or exactly same or better price performance when you move your workload to the cloud. And again, there's a lot of networking that goes behind this scene, but this is what we call a true bare metal and power of bare metal. Well, we do work with a lot of different providers. We have the latest and greatest from NVIDIA. We work with AMD. We work with Intel. We also have, which is not in this slide actually, Ampere ARM. If you are doing anything on the ARM technology, we have that in the cloud. And the good news is we are fortunate or lucky, or I would also say that we have such a good relationship going on with all of these partners. We're the first one to get all the latest and greatest, frankly. The reason behind they move it to us because we're able to move it to the market faster, just because of the automation, the first slide that I talked about. So today, we have so many different generations, but just a quick slide here. On AMD side, we have the EPYC based processor, Skylake from Intel, Ampere ARM that I talked about, and NVIDIA GPUs. On the NVIDIA side, I have one more slide, but on the CPU side, the good thing what we have done is when we launch a new generation. So let's take an example, the new Intel X9, that's what we call it. These are the Skylakes. When we deploy the new X9 generations, the previous was X7s. I have benchmarking numbers that I can demonstrate. We are 30% faster from the previous generations. So the X7 to the X9, but we have not changed the pricing. So the price remains the same. So we all of a sudden get 30% price performance benefit. Even though our pricing is still lower or very competitive in the market, this is how we are giving more to our customers, right? And that's how we have built this cloud. And that's true for any of the instances that we have in the cloud, be it for our GPUs, be it for the AMDs or the Ampere ARM systems. These are some of the GPU lineups. As I mentioned, we have the latest A100s, and obviously we do support some of the previous generations. But that's, I'm not going to spend time on this, but I think this is, the next two slides are important. I talk about how we deploy our Oracle Cloud Infrastructure in the networking with, with a non-blocking network. This is overall typical architecture, not more than 2 hubs. We can provide low latency, high throughputs, right? But for HPC workload, what we have done is, this is what we've built. So what we can do is, we have something called RDMA, remote direct memory access. So Rocky V2, that's what we call it. So we have built our CPU clusters, our GPU, our machines, but they are attached by a special network called the RDMA. So what that provides is, it provides you the lowest latency that you can get in the market in the cloud today. We give you 1.5 microsecond latency. The other cloud who is next to us is around 18 microseconds, right? So we're much, much faster. And what this gives you is you can build huge pool of machines. So one example that we have in this slide is we have customers running almost 20,000 cores. These are physical cores. If you think about it on a vCPU, this might be around 40,000 vCPUs. How we do that? Because we are able to build this networking behind and give the price performance and then cluster that is required to run those kind of workloads. Just not for CPUs. We also do the same thing for GPUs. Today in our cloud, we have one of the largest GPU AI machine learning model running, like as big as 512 GPUs from the A100s. So this is pretty neat, and I think this is because of what we are building the networking stack. That's why we are able to achieve this. Again, I think Ryan also mentioned about file systems. Well, we have one of the fastest file systems in the world today. We have some benchmarking numbers we can demonstrate, but we do support, IBM Spectrum, Scale, BGFS, Lustre, Kilobyte, and many more. If you have your own NFS or any other file system, you can bring it to Oracle Cloud. So no matter where it is, if you want to build that same file system in OCI, you can still do that, right? We'll support that. And our block volume, our object storage, they're one of the fastest right now in the cloud. So that's pretty much there. I mentioned about some of the customer stories. Well, today, I would say one of the top 6 automobile manufacturing companies, they run their HPC on OCI. Let me move out of this slide, and then I'm going to share with you quickly. Give me 1 second. Let me go. Yes. So this is our, I have 2 more minutes. So I'll just play one video. But this is our homepage. If you go to oracle.com, go to our desk HPC. This is our landing pages. There is all our customer story. So a customer like Toyota, they moved their entire workload to OCI. You can imagine how much compute power they're using today to run their simulations, right? Red Bull Racing, they run their entire, this is the Honda Red Bull Racing, the F1, the Formula One. They run their analytics on OCI. We have other customers. Let me play, a small video from Altair. I think you want to hear what I just told you from the customer directly. I think that will really help to resonate the story. I'll play it. Let me know if you can all hear it.
Altair is a company I founded in 1985 with a vision to use simulation to drive design and decision making. Through the years, it's evolved from validation studies replacing test to moving simulation upfront to almost synthesized designs. Now that we move to the cloud, the opportunity to really do unlimited size studies just open the possibilities up.
GPUs compared to CPUs have a massive compute power. And if you develop software which is designed to be executed on GPUs, you get a massive speed up. Altair is developing software which is designed to be executed on GPU hardware. As an example, we have Altair Ultra FluidX, our solution for external aerodynamics. A fully detailed car can be run in a transient mode overnight. And this also opens up the door to talk to the design studios and bring the virtual wind tunnel to the designer's desk. External aerodynamics produces gigabytes of results, and you don't want to transfer these results to your local machine. One big advantage of the cloud is that you can leave the big data on the cloud itself. This means your laptop can be pretty light, but the massive data stays in the cloud. You can sit in a plane or in a subway and still monitor your run, and you can even display your results because we just transfer a very thin slice through your flow domain to your local tablet, for example.
Challenges that customers face are time to market and to increase the speed of innovation. We are launching an on-demand computational fluid dynamics virtual appliance on the public cloud with our Ultra FluidX and Nano FluidX applications leveraging high-end GPUs on the Oracle Cloud infrastructure. We have leveraged the Oracle Cloud infrastructure because Oracle is the first cloud provider to provide bare metal computing resources to match on-premises performance. They have a flat, low latency, high-speed network for highly parallelized jobs, world-class NVMe-based storage both for local scratch and block, and global access to the resources across all regions with high confidence in security and compliance. We were looking for the best price performance, and we found that with Oracle Cloud Infrastructure.
Perfect. So I just want to make sure, what I talk about, you hear it directly from our customers. That's it, I guess, from my side. But thank you again, everybody, for joining today and hearing to me.
Brian, just a
Thanks,
moment. I'd like to offer our webinar attendees, my friends at Oracle Cloud have partnered with us to provide free POCs. So if you sign up between now and the end of the year for a free POC, we'll make sure that that there's no charge from Oracle Cloud. Right, Anoop?
Yes. Yep.
So I just wanted to say that, Rian, and then turn it back to you and Sue.
Thank you very much, Mr. Eng. Yeah, so I do want to finish off and just quickly, a few seconds, go back to what we showed you earlier, just as a final result showing what we used on OCI, which Anoop beautifully explained, where remember we had the workload in there. So now my workload is completed and my compute nodes in the meantime went into busy and we completed our workload and all my compute nodes are done. So I didn't even need to look at that. I was listening to Anoop and in the meantime that was happening. So it just shows how all of that are automated, just as a finish off. Yeah, thank you very much, Sue. So I think, handing back to you.
Okay.
The slide up for us.
Great, thank you. I'd like everyone to know that, again, the POC offer is open until the end of the year. And if you'd like to contact us for more information, please email us or give us a call. Our contact info is info@adaptivecomputing.com, or you could email me directly, sdegram@adaptivecomputing.com. So again, thank you very much for taking time out of your day to listen to our webinar. We appreciate that you've done that and hope that you have a great rest of your day.